So to model our scenario, we need another type of gateway, which is called the OR gateway. The OR gateway, a diamond marked with a no symbol, is used to create and synchronize n out of m parallel flows, meaning that we have a number of potentially parallel flows, and then we will trigger a subset of these. So specifically, the OR split, also known as inclusive decision, takes one or more branches depending on the conditions in these branches. So like the XOR split, we need to annotate each of these outgoing branches of the OR split with a Boolean condition. And if the condition turns out to be true while we are executing the process instance and we got to the OR split, then the OR split will send a token to that particular branch. It sends the token to one branch, to two branches, or to any number of branches out of all the possible branches that come out of this construct. The OR join, on the other hand, proceeds when all active incoming branches have completed. So here the keyword is active, meaning those that are currently being performed and eventually will complete. Or in tokens terms, which token is going to arrive at the doorstep of the OR join through that particular branch in which the token is flowing. So if only one of all the incoming branches of the OR join is active, then it will only wait for the token to arrive from that particular branch. But if more than one is active, then it will wait for all those branches that are indeed active, hence synchronizing all those tokens and only sending one token to the outgoing branch, similarly to what the AND join does. But let's see a concrete use of the OR gateway in the context of our own example, the order distribution process. So we said that this process starts when the order is received, upon which we check the order line items. Now let's assume that the order only contains products that are stored in the Amsterdam warehouse, in which case we will send only one token to the top branch of this OR split, and the activity forward suborder to Amsterdam warehouse will be performed. So since the corresponding OR join in this OR block only has one of its incoming branches that is active, the top one indeed, it will only wait for a token to arrive from that top branch. And once that token arrives, the OR join will proceed by sending that token out to the outgoing branch. Similarly, if the order only contains products that are stored in the Hamburg warehouse, we will forward the suborder to the Hamburg warehouse, and then the OR join will wait only for that one token to arrive. But if, like in this scenario, both conditions can evaluate to true at the same time, meaning that the order contains both products that are in Amsterdam and in Hamburg, then the OR split will generate two tokens, one for each outgoing branch. Hence, the two branches will be performed in parallel. They will be performed independently of each other in any order. So for example, the activity forward suborder to Amsterdam warehouse was faster than activity forward suborder to Hamburg warehouse. But once both tokens have arrived at the doorstep of the OR join, one for each of the parallel branches incoming to the OR join, then the OR join will synchronize these two tokens and send only one token to the outgoing branch. So it will merge the two tokens similarly to what the AND join does, and in our example this means that activity register order will be performed, upon which the order will be completed.